Hi everyone, this is Ray of RV Tech Tools. I wanted to do a video today on a new feature that I'm putting in RV Dash based upon a request from a customer. This particular customer had issues where some of his RV Dash gauges were not matching his analog gauges. In the case of a speedometer, it not only didn't match the speedometer, it didn't match his GPS. So he realized that there was an issue. As it turns out, this is really an issue with the DDEC not being properly calibrated. However, I figured there might be a fairly straightforward way that we could go ahead and modify the application to allow you to make adjustments to what the data is that you're displaying on your RV Dash application. Let's take a look at that. In particular, I'm running it in the simulator, and I've attached the simulator to a dump that was collected by the RV Dash app by my customer. What this is going to show me is the data that he was seeing on his particular vehicle. If you look specifically at the road speed indicator, it shows 56, 57 miles per hour. He indicated to me that his analog gauge was showing about 65 and that his GPS was actually matching the gauge. So here we have a discrepancy at this point that the data coming down the CAN bus doesn't match the actual data or the physical response of the vehicle. So what do? I think first of all what we have to do is kind of look at how the application works. What you're seeing in front of me here now is an email that I received from the customer, which was generated by RV Dash using the Open Debug Log menu option, which you can reach from the gear menu down in the bottom right hand corner. When you finish capturing the data and email the log, it generates a two-part report to me. The first part that you're seeing here is a listing or summary of the various parameters, which is called a PID, parameter IDs, that are reported by the app, and their last value that was seen on each of those parameters. So what you see right now on the screen is a listing of several of the parameters that were captured by this particular device. If you'll notice, the road speed here was shown as 57.5 miles per hour, and if you look down a little bit, this cruise control set speed indicates that he had set his cruise control what the engine believes was 57 miles per hour. Now remember that he had suggested to me that this was incorrect and that should actually be 65. Below that is the actual data that was seen by the CAN pod and ultimately transferred to the application. Now this may look like gibberish to you, and it really kind of is, but what's important is the last part of each one of these lines here. These indicate the message that's coming in, and each of these parameters indicates what PID number or parameter we're looking at and what data is following. So what the application does is very simply decodes this information on the fly and turns it into data that you see in the application. Now it's important to understand that there's nothing in the application that understands what kind of vehicle it's connected to or anything about that vehicle. It doesn't understand anything about axle ratios or temperature variance or anything like that. The data is all provided by the DDEC computer on the coach, and they are sent down the line, captured by the CAN pod, and turned into this ASCII stream. The application RV Dash then simply decodes this and displays that information to you. Okay, we have now opened the simulator, and in particular I am capturing or running a capture of the data from the customer that shows the problem, as I mentioned before. Now it's actually important to kind of understand how the data works. We showed you in the previous part of the video that there was this jumble of information that gets decoded on the fly. What it turns out is every parameter, such as road speed or inlet pressure or oil pressure, has a specific PID or parameter identification number. It then provides data that comes in, and that data has to be multiplied to make the proper units that we're talking about. Let's take a quick look here at the specification that actually defines how this works. If you look at this, parameter number 84 is road speed. This is the one of the parameters that my customer is having a problem with. If you look at this, The parameter is 1 character or 1 byte in length. It's an unsigned short, meaning that it has a value from 0 to 255. Every bit in those 8 bits that define the 1 byte are worth a half a mile per hour. So this means that the range of the data coming in can be converted from that 0 to 255 to 0 to 127.5 miles per hour. So that default multiplier is 0.5. So what happens as the data comes in, this default multiplier is applied on the raw data that comes in. It converts it. In this case, his unit was showing 114 generally. It was converted to 57 by the default multiplier and displayed in the application. So that's how it works. What I'm doing now with RV- is allowing you to modify the default multiplier and therefore change how it works. So remember here, the displayed value that you see here in the display is equal to the incoming data times the default multiplier. Now what I've given you is the ability to change that multiplier and also to add an offset. So let's go into the gauge editor and show you how to do this. So I'm going to click and hold. We go into edit mode by going into the gear menu, and then I'm going to click and hold for 2 seconds on the gauge that we want. Now this is the gauge, the Rosebead gauge that we've been looking at. Its default PID value 84, which we saw in the specification earlier. Its min and max ranges that we're going to display in the gauge. And then here is the default scale factor and offset. Now generally the offset is always 0, but I've added this so that we can actually change this. So now let's take a look at what it takes to convert this road speed of 57 to 65 to more closely match his real world speed. So if we take a look in a calculator, and let's actually bring up a calculator here, I think we can do that and show you what's going on. So his road speed is off by a certain percentage, it appears. So I'm going to take his 65 expected and divide it by 57. And there's a factor that it needs to be adjusted up about 14% approximately, as you can see here. If I multiply that number times the default scale factor, I've come up with a number of 0.5702 approximately. So this is what I'm going to change the scale factor to get a speed that more closely matches what he wants. So I'm going to change this to 0.5702. I'll click down. I'm going to leave the offset alone. And if you notice now, his indicator is indicating 64, 65 miles per hour. I'll click on Update Gauge, and then to make that permanent, I'll save that edit. Now if you look at the gauge here, it's reading closer to what he's expecting, 64, 65 miles per hour. Okay, let's take a look at his second problem right now. So this one, he was indicating that his oil pressure was indicating 42, 43 when it should potentially have been closer to 48. So what we need to do is make a correction factor there as well. Let's take a quick look at the specification on oil pressure just to learn a little bit about it. Now that's PID number 100, as you see here. It is also a 1 byte character, which represents that data, which is a value from 0 to 255. It has a bit resolution of 1/2 psi. So this means that the 0 to 255 represents an oil pressure of 0 to 127.5 psi. So we're going to need to make a correction factor to apply to the incoming data to make it more closely display what he's expecting. So we're going to go in, I'm going to edit like we did before, and I'm going to click and hold for 2 seconds on his oil pressure gauge. This brings up the oil pressure gauge now in the gauge editor, and if you can see, it is PID number 100, and its default value is 0.5 psi as we expected. So I'm going to go in and I'm going to open up the calculator app one more time. And this time I'm going to try to calculate a correction factor based upon his 48 expected versus 43 displayed. So I'm going to type in 48 and I'm going to divide by 43, which shows that I need about an 11.6% correction factor. I'll multiply that now times 0.5, and that gives me a value of 0.5581. So we're going to come in now and I'm going to change the 0.5 to 0.5581. Now watch the value change when I click this. It's jumping around between 38 and 40, but when I click on it, it's now between 43 and 45. So that more closely matches what he wants, and we'll go ahead and update that gauge, come back, click on the gear menu, and save that edit. So now the oil pressure is indicating higher than it did previously. I'm going to go ahead and stop this real quickly, and we'll restart it just so that we can get back to the part of the data that was showing it at 43, just to show that it's now different. So we're going to start this back up. This restarts my simulator and the incoming data. And there it goes. And now if you notice, it's up to 46, 48, 49, which is more exactly what the customer expected. In the next part, we'll go ahead and show the coolant temperature, which he also indicated was a problem. Okay, we're going to look at the final gauge that my customer indicated that he was having a problem. And we're going to look at a couple of different ways to change this. In particular, we're now looking at the coolant temperature. It's showing 164, and he indicated to me that it should have been showing about 185 when it was showing 165. This is early in the capture. It does get higher up towards 165, but it is averaging right there in the 164, 165 range. So let's go into the editor one more time and select the coolant temperature gauge. Now, taking a quick check over in the specification, which we don't need to do, but I'm just trying to reinforce the idea here. The coolant temperature is parameter 110. It is, again, a 1 byte character, but this time the bit resolution indicates 1 degree Fahrenheit. So this makes a range from 0 to 255 degrees Fahrenheit. That's the incoming data. And so that's the default multiplier will be 1, and it indicates a degree Fahrenheit per bit. So let's go back here now and take a look. We're in that gauge, and indeed it's a PID value of 110, and its default scale factor shown here is 1, like we said. We also have the offset here, so let me show you something just a little different. There's no magic way to get this. We're kind of fudging the incoming data because what we're getting from the ECM may not be correct. Now we could change the scale factor we've seen before, but let's say in particular this gauge just happens to always indicate 20 degrees too low. So right now it's at 162. I can put an offset of 20, and when I click on it, it automatically moves things up by 20 degrees. So this is another way to do it. Now you can adjust both of these factors to get a more closely matched one to your particular unit. I can't give you any specific numbers because it depends entirely on how your gauge seems to be misbehaving. Let's go back and let's say, for example, that we want to use a mixture of a new factor plus 10 degrees. So now what we have is we're at 175, but we want it to be 185. So let's go back to our calculator here, and now that we've got it kind of in a partial mode, we're going to take 175 divided by 165 times 1. Okay, so what we want to do is bump this by 1.060. So we're going to come in here and we'll take this 1.06 and now we're again back up in the range of 180 to 185. So I'll go ahead and click through this, update the gauge. So this was a compound adjustment where we added 10 after multiplying. So we multiply the incoming data by 1.06 and then add 10 to it to get a coolant temperature, again, that more closely matches. So this gives you the basic ideas how you can make adjustments to more closely match what you believe is the correct values. Honestly, what I'm going to suggest is that you may want to talk to Prevost and have them adjust the calibration in your DDEC computer to closely match what's really happening. In the case of the speed, this could have been due to a different rear axle or an axle ratio adjustment that was made, and they need to recalibrate the ECM so that it understands per revolution how far you're going. But this will allow you to make a change in the displayed values to give you a little more confidence in what you're seeing. I hope this makes sense. If you have any questions, do not hesitate to contact me. Thanks. Hi, this is Ray. So I'm bringing you this extra piece here on the video because I missed a couple of important pieces of information when I finished up the video earlier. So I'm restarting the CanPod simulator here, again with the changes that we already applied yesterday. If you'll notice, the road speed now is up around 65. That was augmented up from about 58. Coolant temperature is currently 182. It will get as high as 185. Previously, the customer complained it was reading 172. And oil pressure is now 48, and where it was about 5 pounds low previously. So the very important pieces of information I wanted to pass on today are this. First of all, the landscape and the portrait gauges are totally independent. If you change the orientation of your iPad, which I'm going to do here, you'll notice now that the road speed is back down to 56. The coolant temperature is back down to about 162, and at the very bottom here, the oil pressure is down at 40 to 43. These are the original values because these gauges have not been modified. They are totally independent from the landscape gauges. If I go back now into landscape mode, you'll notice that they're back to the modified values that we were expecting. So make sure that if you make modifications to your gauges and you happen to use both orientations, that you need to make the same changes to the gauges in both orientations. Lastly, but also very important, is that if you get yourself completely messed up and you don't know how to kind of get back, you can always go back to the factory defaults and it will reset all your gauges. Just go to the gear menu and select the second item down, reload defaults. And that will reset your gauges, not only position and size, but also back to the default scale factor and offset. So if you notice now that our gauges are back to reading 56, the coolant's back down to 162, etc. So I hope you find this helpful, and I hope that if you have these kind of issues with your readings on your CanPod, on your RV Dash app, just go ahead and make some adjustments and make them closer to what you are expecting. Remember though, this is actually a DDEC error, and this may indicate that you need some kind of calibration done of your sensors and your DDEC to finalize and fix this problem. Take care. Have a great day, guys.